So I'm going to talk about server-side rendering and without any hexes because you'll see. Hi, my name is Anton. I'm originally from Ukraine. I'm a web developer. I'm a smart TV developer now. And I work at Nebula, which is a video streaming platform created by, owned by, and maintained by a bunch of YouTube creators or just creators who needed some place to just upload videos and their creations without ads, without algorithms, and without worrying about monetization. Like some things here are not safe for work, so YouTube won't like it. And I need to click. Yeah. So my story with SSR at Nebula starts before I joined Nebula. So in 2021, when I got interviews there, I'm not sure how the topic came up, but yeah. So the topic of like pros and cons of SPA. Like, should Nebula be a single-page application? Like, it's just pages with videos. Why does it need like all the animations, all the logic, all the client routing, and all that? It's still single-page application for better or worse. But my point of the conflict with Nebula being an SPA is it's bad for SEO and for social links. Like when you send a link to your friend or post it on Twitter, it usually shows like a preview. And Nebula is like just regular single page application with React in the middle, with some React query layers to contact with HTTP APIs, like for content, for user info, for payments and all that, and React router to do some client-side routing. All that just gets packed into JS, CSS, HTML, uploaded to S3, and served with CloudFront. They're easy to distinguish because S3 has 3 cubes, and the CloudFront obviously has a cloud on it. So all that serves you a nice, pretty page with video, with a player, with all that. And when we, during the interview, looked into the network tab of Nebula, it is not that same tab because I didn't make screenshots of that, but there was no open graph data, which is used by Twitter and messengers to distinguish what image to show, what description to show, is it a video or not, and all that. All this was rendered just by client for nobody to use because like browsers don't care about that. Users don't care about this data, and bots and all that just don't see it because it's not in initial HTML. Google still sees it because it's Google and they have money to render everything, like to set up all the JS VMs and all that, but Twitter and all that shouldn't. But it still showed that preview for some reason. Neither me nor my 2 interviewees, one of whom became my team lead and another one is CTO, knew why it's happened. Like we know that for some reason it just shows it. We know that Twitter, even in 2021, couldn't have money to do like what Google does, like just set up all the JS stuff. We thought, okay, maybe I guess everything runs JS. Just the fact. So 2022, I already work at Nebula for a few months, and we encounter some problem. We had a problem with stale thumbnails. So with the same exact feature, like link previews. For some reason, even when creator uploaded new class in our case and changed the thumbnail, it showed properly on the site. But in link previews and all the tools to debug them, it still showed like this. And this is why it showed it. Because this is what bots, what Twitter, what Slack, what I think Facebook saw on Nebula. Like this layout. Because, as I discovered, and basically everyone at Nebula but one person discovered that this slide is a lie, because there is a lambda there between CloudFront and S3, which did checked user agent for this regex. If the user agent has something from this regex, it will roll out user or bot, I guess, to another page. Which is because this line doesn't include curl, whatever. It was very fun to debug. Why? So when we uncovered this project, Nebula Meta, because of meta tag, we just decided, okay, yeah, we have 2 projects. One of them, nobody knows about it because the person moved to another part of the company, basically moved away from the development. So we cannot just open a ticket for them and say, okay, do that. It contacted old APIs. So Nebula started as basically a project for 2 sprints. So a bunch of APIs, content API, user API, and payments API were third-party. But during years of development, some of them, like content API, user API, became ours APIs, maintained by us. So when creator updated the thumbnail, we updated the thumbnail in our API, but the Nebula Meta didn't know about our new APIs. It still showed the stale data. Also, Nebula Meta didn't know anything about classes that still were in development in a huge project. It didn't know about WhatsApp, Telegram, or random blogs or whatever, because they didn't have anything like that. They are not Twitter. So we just decided, okay, we need to update Meta to fix a few bugs, to update them, Meta, to know about classes, move to SSR, and just remove the Meta project. How we approached this problem? Okay, we decided we need to do SSR. First, we need a server. What does server in SSR do? Yeah, it has 3 jobs: to determine what page to show actually to the user, query data from aforementioned HTTP APIs, and render the page, which seems to be easy. Okay, we already have React Router, we already have React Query, we already have React. All of this is solved problem. But nope, because there are some missing parts. The web app does a lot of stuff, including connecting to browser APIs. There is no location ref in Node on the server because there is no location per se. Node project can be just a script without any server side. In our case, we got lucky because Express has a React request object with URL, which is basically the same as location ref. Don't quote me because it's the same for this talk. If you want to quote me or correct me, you can contact Tudor or Dmitro and do your own talk. So there is no window, there is no document. There are ways to work around it, but the most straightforward is just check if there is a window. Either with a fancy function that basically always falls on a server, or by doing Elvis operators and all that. Elvis operator, for those who don't know. Yeah. So with that, we solve the problem of browser APIs. We have some defaults or unchecked for them. There is also React APIs, which is useEffect and useState. UseEffect is safe on a server because server-side rendering, React server-side rendering doesn't call useEffect. It's just no op. So it's fine. It's fine. useState, on the other hand, is trickier because it's still it doesn't do anything. It's pretty safe, but it usually has defaults that use the window or something. ideally, we would want to separate use state and use effect. Like Nebula is written in TypeScript. In an ideal world, TypeScript would just see, okay, you are using window outside of use effect, check for it. You're using window inside use effect, it's fine, we don't care about it. But if somebody knows how to do that, please contact me. The contact information will be in the last slide. Because I couldn't find any way to do that, we just had good old smoke test. So okay, just check every URL in the app with contacting HTTP APIs. Check, is it 200 or 404? If it is, then it's fine. If it's 500, okay, something is wrong. Maybe server tried to access browser API, and that's why the 500 was occurring. So close enough, I guess. We can just check for with Elvis operator and all that. So we basically have this. Okay, we have React router resolving what view to show. URL is the one from request. Render it. It's done. But the app that will be rendered won't have any data from queries from the APIs because we didn't know why. Because so React Query has like a notion of query client, which does all the logic for loading the data. So and providing some context for React hooks for React app to call the hook like use query. This query will has some info about, okay, how do I fetch the data? It is just a promise. If it resolves, then data is ready. If it doesn't, then there is an error, all that. But if React Query uses hooks, and I guess it is either or both, use state and use effect, it would mean then just lie to us. It's not fine, because if server side doesn't call use effect, then React Query has no way to fetch. Like there is nothing to be an effect on a server. So we need to do the fetching ourselves. How will we do it? By just rendering the app without any queries or without data. React Query will see, okay, what queries are needed for this render. The query client will have them. Will go through every query, so many queries, it will get worse. And we reload or render the page with data in query client. So we just get some queries. Who works with React Query? Okay, 4 people. So don't care about everyone else. Just we need to go through all the idle things in the client manually instead of relying on the client to do it. Go through every one, wait for them to settle instead of just raise or all. Like all settled is okay. If it fails, it's still fine. Like we don't care. We'll handle it later. Still try to fetch every single promise in the array of fetches. And we find rejected promises just in case, just to handle them, like the errors, instead of just ignoring them. And render the HTML will look like this after all this work. Like, okay, here's query client, here's router, here's the layout. This slide is for those who care about React Query. You don't, so just it's fine. The previous slide was a lie, so don't worry about it. If extract and fetch queries failed, we need to do some responses, error responses on server. We'll do usual stuff, manually set the headers and status and all that. Then remember to mention that I do not care about Next.js again. Like I believe everything that I'm talking about can be done basically automatically with Next.js. Is my understanding from the fans of Next.js. I'm not a fan. I'm used to doing everything myself. But I'm sorry. So yeah, render HTML. If querying the API fails, and rendered HTML is just initial index.html. So the file that was initially in S3, like without any metadata, which is just also fine. Like user will fetch the data in the browser, and at some point bots will update the thumbnail or whatever. And CDN will take care with 500s. I did not mention another part of the web app is user sessions, which are pretty important for the web app, but just not important for SSR in our case, because like it adds a lot of complexity. Like how do we manage it? It adds problems with CDN, so it makes it way harder to cache anything. Like if every user gets its own version of a page, then if your neighbor loads the same page as you, like 5 minutes ago, you won't get any advantages of it. You will wait for the server to respond basically the same. It adds lag and it adds risks. So like with Steam, who tried to do did server-side rendering, but something went wrong, and just caching serves someone's pages to anonymous ones and vice versa. So yeah, let's return to the initial idea of SSR. We wanted to just solve link previews. So for link previews, the only important part on this whole screenshot is just that, like the URL and the title. And maybe like this also, but it's not the part of the page that was on the screenshot. So we can just remove everything below the body and serve that. And it will solve all our initial problems. Like we got new ones, but this will solve the problem in 2022. So we can update our goals of the server with just render the head and keep body as is. And when we are talking about head in React, we need to protect the head with React Helmet, which I still love the fact that it's developed by NFL and the logo just perfect. So how do you work with React Helmet? You just on a server, you just render the React app into the string. You ignore everything that React render to string returns. You reach to render static, which will return you an object with some properties. And not sure about you, but we just replaced with regex the bare bones index.html. Is the index.html created by at the time create React app. Now it's Vite, but just replace it, and we are fine. Like we have, this is now the response from the server. Like every metadata tag in here and nothing in the body, or basically nothing in the body. Just use JavaScript, please. I won't talk about deployment because all the deployments are way too different. We I guess just do Docker or something. But if you're uploading to S3 or some other block storage provider, keep all assets available, because I'm really annoyed by the fact that like Vercel and Cloudflare, which is Flare, yeah, just remove or make them unavailable, all assets. So when you do rollback or rollout, the clients might be in different states. So they will try to load 2 new or 2 old assets, which is product management won't care about that much because it's like, when does it happen? Like it's basically never, but you know now and you will care about it, so just keep it. Yeah, the last part of delivering the server-side rendered pages is CDN, which is this cloudy looking box. In case of Nebula, we are using CloudFront, also Fastly, also Cloudflare. And I love the fact that two CDNs that we are using share CF abbreviation, just very comfortable in Slack communication. So what does CDN do? It can route different URLs to different parts of your application. So it can be, can route like jetlag URL, which is dynamic one, hosted by or managed by content management system to our node application, and like static files to S3. It can also modify the requests that are coming to the server or do the Lambda itself instead of routing to the server. It can modify the headers, both in responses and requests, like user, yeah, we are keeping the monkey and the dog, I guess, in this example. And it cache and reserve the old responses from a server to other users for short time, helping a lot with load balancing and just load of a server. Because internet is crawling with all these bots. Some of them are fine, some of them are just under your skin. And even if you don't have any scale, they will still find you. So any caching, either CDN one, paid one, or free one with Nginx or Caddy will help a lot. Yeah, some terminology. This will be a CloudFront heavy section. Viewers are the clients. Origins are whatever actually does the response to the request. Viewer request is number one. Origin requested is number two, and origin response is number three. Distributions are configs. I'm not sure why CloudFront decided to name configuration distribution, but yeah, I might use both terms interchangeably. So caching. Caching is a big topic on itself, but in the most basic, caching is controlled by two headers, so even one is cache control, originally named, which has a bunch of directives in it. The most useful ones are maxage that are used by is used by both browsers and CDNs, smaxage, which is used only by CDNs. Why would you want to separate them? Mostly to recover from errors. Like if you cached some broken page in user browser, there is no way for you to update the page there, like the asset, aside from calling your user, telling them, okay, do Command-Shift-R or something, whatever the browser they're using. Maybe they don't even have command. So at Nebula, we don't use maxage that much because, like, okay, there is no ways for us to control the cache. While with smaxage, we can just click a button in CloudFront UI and invalidate every cache on CDN. But yeah, there are also other headers. You can read about them on MDN. I won't talk about it. Yeah, so viewer requests are way harder than just a URL. Like it also includes a bunch of other stuff. And by default, browsers only care for caching, only care about URL. So it's path, there is host, and that's it. So if URL is the same, even if everything else is different, so like cookie is different, if the URL is cached, it will be reused from the cache, the response. So how do we signal to the browser, like, okay, what's important in all this mess aside from the URL? With a very header, which is just a list of headers, about which we are caring about. So with with accept language and cookie, this whole stuff becomes this, and all that is now cache key. So when browser will check the cache, it will check, okay, is there something for this cache key? If there is, then here is the response. If there is none, then we'll go to the server. Very header is used not only in the browser, but also on CDNs, but with varying degree of success. So CloudFront supports it just fine. Cloudflare basically ignores it. It has ticket for years about that, and like the solution was, okay, we did that for images. Pay us for image work. That's it. So if you want to serve your JSONs with from Cloudflare, there is no way to do it still. And I'm not mad. So CloudFront policies. Yeah, the very header is not that flexible. So URLs can be very long, and the server might not care about every single part of the URL. So for example, we have these 3 requests. With different query parameters, with different cookies. Nebula doesn't care about analytics at the moment, and the ref parameter is basically for marketing, and the server also doesn't care about it. So ideally, we would want to have all these 3 requests have the same cache key. So CDN, if somebody loads any one of them, CDN will just repeat the response for something from the past. To do that, CloudFront has 2 things, like cache policy, which is just, okay, here's a list of the stuff that is important for the cache. It can be query params, it can be path names, it can be headers, cookies, whatever. So in example cache policy, we can just say, okay, we care about queue query param, and we care about cookie session cookie. Yeah, and that way, all of them, as you can see, like just with colors, have the same cache key. Origin request policy is a little bit extra. Like if you want to add something to addition to your cache key and still get your request, like, okay, we will add something to the request that goes to this. Yeah, I forgot about something, but it will be fixed by the next slide. So if something is missing in cache key, we can define additional data. Like, okay, we don't care that much about analytics, but we still want to occasionally get the request with the analytics cookie, which leads to a lot of bugs because, yeah, if some data is included in cache key, not included in cache key, but included in origin request policy, then the behavior is basically undefined. Like whoever got to the server first, like whatever browser or whatever analytics cookie will occupy the URL for however long you set up your caching. So just if you are using CloudFront, just avoid origin request policy. Yeah, there are ways to use some defined policies. There are ways to write your own. If you do write your own, don't have a restricted list of query params that to include in the query cache, because, like, okay, if you forgot something to be included in this cache, it will lead to bugs that, as I said in previous slide, because I had to ask how I know. Yeah, so what and how to cache. All the public files in the repo that is usually in public folder without any stuff in it, just don't. Not worth it. Just it's fine. You will manage. Everything with hashes gets cached for a long time. In this case, I don't remember how long. I think it's months, maybe a year. Something in seconds, like 86,000 seconds. And it's public data, so it's not. It doesn't depend on user data, so it's public, so CDNs can just use the same file for everyone. And this is a S3 CLI option to set all the headers when you upload the file to S3. So now we are going to see our SSR. There are two, in our case, in case of Nebula, there are two URL types that need caching. This one is just the general page, like the one that won't get changed until we do the redeployment. Like it's list of videos. It doesn't change the thumbnail on the link preview. Doesn't change title, so we can just cache for however long. It's just in our case, I think it's a day. It can be longer, but just to be safe, it's just for a day. We are caching videos, classes, featured, some FAQ pages, and all that. Pages that are controlled by CMS, so the ones that creators can upload their videos and change the thumbnail, need a bit more finesse, I guess. So we need to have a way to set the cache duration in the page itself. I need to change the order of slides. So you need the page to define, okay, this page can be cached for 5 minutes in our case. And that can be done by React routers. I'm not sure about React Router 6 because we are still using React Router 5 because React Router 6 for a long time had a big bug with it. But yeah, in the fifth version, we can just pass an object and click, check it when we are setting the headers of the star response. Like, okay, if there is something in the object, then use that. If there is none, then just use whatever is the default one. In one of the previous slides, I mentioned that CDN will take care of 500s. It can be done with failovers, which is just defined in the same distribution as the policies. They are the way to tell AWS to, okay, try another origin. If this one fails, just try another one. Usually it can be like the same URLs, but for 500s, we are basically serving the index.html, so like the default one from S3. So if our app fails for some reason, we can just serve the user the same page with different error code. So the human user won't notice anything different. Like it's the same layout, it's fine. And for bots, yeah, the preview won't load, but it's also non-critical. So it's also just fine. But yeah, how it all went. It went, I'm biased, but I liked it because we discovered another bug with CDN. So when we did any request to the page, it didn't do any caching because of misconfigured this section. So it's just skipped caching. So every time when you loaded the page, it would take around second and a half just to render the same static HTML with properly updated CDN and all that. Now it takes like a frame of time, so it's 16 milliseconds. Google discovers that Nebula has videos because of all the Open Graph data. Like, okay, now they know that there is a video. It has this duration, which is also great when somebody just looks for a video. It has a nicer layout on the search results page. Way more messengers started to serve the link preview. So WhatsApp, for example, which was a big ask from some parts of the world, like Spain. And yeah, the server-side component is very useful tool in the tool belt. So whenever we have now some problems, like okay, we need to change the domain. Without the server-side part, it would be hard to transfer the session, like not uglier to transfer the session from one domain to another. And when we have a server, we can just, okay, here's the cookie. The same cookie just gets transferred in the background, basically. So it's nicer to do. Yeah, and there is still like some issues with cold caches. So there are, yeah, cold caches is when the page is not in the CDN. It still takes too long. Like it can take 10 seconds to serve the initial page, which is will solve at some point, but for now it's again fine. So what I talked about today, why we started to do SSR at Nebula, how we did it, and what CDN and all that was needed to do the server-side rendering. Yeah, thank you. The link has a way better explanation of everything without any missed parts, which were skipped because, wow, 36 minutes. Okay, because I had no time. It's way shorter than the text itself, and I'm Zemlyanin on all the socials and all that. Thank you again. Questions?
Yeah, I have a question. When you were talking about the server-side rendering at the beginning, did you consider using a browser in Node? Did you consider using desktop?
We did, yeah. It's another part that I cut from the talk. It would solve it, but it's way more resourceful.
It's expensive.
Yeah, so it's like we are not at scale to do that. Like as I said, Nebula is just creator owned, so there is no VC to just pay for checks on Amazon and all that. And we have like 5 total developers at Web, Roku, and Smart TV, which are just jumping around between the projects. So there is just no cash for that, and no people to support the JS DOM tooling. Like it still gets updated rather frequently, so it will require some maintenance, and we just don't have resources for that. When we have something, just write once and it will work.
I mean, if you don't have pages that changes a lot, then you can just generate them on request. But
yeah.
Any other? So I've been working with Svelte kits for the last year, and it does server-side rendering on the first page load by default. I've actually never worked with React before. I'm just curious whether you think a framework like that would solve all or most of the problems that you dealt with, or would you still have to do some of these things?
It will solve most of the problems. You'll still need to, like, I don't think that Svelte solves CDN or some use case specific stuff. Like I don't know how they would solve the issue of caching different pages for different time. Like when it depends on the dynamic URL. Like the videos URL is simple example. Like we have a bunch of top level URLs like the jet lag one. Like, okay, if we cannot have a list of channels, like jet lag is a channel on Nebula. So we cannot like know whether / something need to be cached for a day or for 5 minutes. So there will be still some problems to be solved by Svelte, and Nebula was a React app, so even changing the build tool was an adventure, and changing build tool, language, basically language. My understanding of Svelte is that it's like JavaScript or JSX, but more different. So yeah, putting that into the mix, it's just not a great idea for.
I was more curious about, am I going to have to solve some of those same problems in my own?
Yeah, you will. Yeah. Yeah, but Svelte will solve a lot of that. Like you won't need to deal with Express server, for example, mostly. But yeah, if you just go with whatever Svelte recommends you, it will be easier. It will be less adventurous, but still easier.
Thank you.